All right, factor completely. Now this is a weird one to factor completely because I see a trinomial, I see a binomial, and only one of these that I see. I mean, sometimes there's more than one. I see one of these, I can take a greatest common factor. I can take a common factor out. And that's actually what I want to start with. I want to take out a common factor. Now, I'm going to be extra with writing. I'm going to write as much as possible to try to help you guys see my step-by-step processes. And so, let's look for the greatest common factor first. Is there a greatest common factor in this trinomial? Is there something I can divide each of these terms by? Can I divide that term, and that term by the same thing? And the answer is not, dog. Okay? Nope, can't do it. What about this guy and this guy? Can I divide each of those by the same thing? Yeah. If you look at the coefficients, the 2 and the 4, I could definitely divide both of those by 2. What about the variables? I could divide that one by x, and I can divide that one by x. Okay, so that means we can take out a 2x from each of those. And you could write it like this. You could say 2x and 2x and take it out like that. And what you're essentially doing is you're doing a division problem twice. Now, if you're lazy, kind of lazy like me, you won't write it like that. You'll write it like this, and you'll say 2x, and you'll divide this one by 2x, and then you'll divide that one by 2x, and you'll write out what you get. So, let's go. X squared plus x minus 6, and then I'll put the 2x right here, and then I'm going to write right here what I'm going to get after I divide. What is 2 divided by 2? Uno. Okay, now Uno's a ninja. We don't have to write him. What is x squared divided by x? X, right? We go 2 minus 1. You subtract the exponents, okay? And you don't have to write the uno. You just write the x, okay? Okay, now what is 4 divided by 2? Dos. And then x divided by x? Uno. Okay, but we don't have to write that uno because uno doesn't change anything. All right, so now we have x plus 2. All right. Did we do something? Yes, we did. We factor out a greatest common factor. Now, is there anything I could do to factor this binomial? No. Now, this guy's a bi because there's 2 terms. 1, 2. Okay? And this guy right here, do you guys remember what he's called? He's a mono. Okay, and then we have our trinomial. Now, a trinomial. Now, there's different patterns in order to do this. Okay, I'm going to use the big X method because that seems to be, well, that one's my favorite. I don't know if that one's your favorite, but there's also the the box method. So here, let me do the big X first, and then I'll show you guys the box method. Okay, the goal here is to take the number in the front and the last number, multiply them together. That number goes right here. And then you take the number in the middle, and then you put that down here. And what your goal is you're trying to find 2 numbers that multiply to give you, Oh, that's not 6. It's negative 6. 2 numbers that multiply to give you negative 6, and then add to give you positive 1. So what are the 2 numbers that'll multiply to give you negative 6? And then add to give you positive 1. Now, if you are kind of lost with this, hopefully you do something like this. 6, and then you go, okay, 1 times 6, 2 times 3, and then, see, I go in order, 1, 2. My next number would be 3, but that number is already here, and so I stop. Those are all the factors of 6. Okay, now which of those 2 can add together if I make one of them negative to give me positive 1? And you say negative 2, 3, hopefully. And so we're going to use negative 2 and 3 to factor this. And the way we do that is we write 2 binomials. One of them's going to say x minus 2. One of them's going to say x plus 3. And then we write the rest of our factors, 2x and then x plus 2. And we're done. This is completely factored. We have all the factors. Now, we can always test it, and we can always multiply everything back out to see if we get right back to where we were. Now, the shortcut that I did here with the big X, I can only do because of the leading coefficient. The leading coefficient is 1. If the leading coefficient is not 1, you have to split up the middle term with the 2 numbers that you just found. Okay, and I'm not going to do that because it's a lot of writing. I'll do that when I have to do that. All right, so we're done right now, but I'm going to do something extra. I'm going to show you guys how to do it with the tabular method. Okay, so for the tabular method, you got to draw a table like so, like this. Okay, and what you're trying to do is you're trying to find the binomial that goes up here and right here. Okay, so first thing we're going to do is we're going to plug in the x squared right here, and we're going to plug in a negative 6 right here. That's the first term and the last term of the trinomial. And then right here, we have positive 1x. Okay, that's the middle guy right here. And you're kind of doing the same thing that we did right here, but maybe you're doing it in your head. Maybe you still use the big X. I don't know. What you're trying to do is you're trying to find two numbers that go right here that will multiply to give you -6, but then add to give you +1. It's kind of the same idea. Maybe you wouldn't use the big X, though, because everything's already organized for you like that. And so you're thinking to yourself, well, what about -2 and 3? So that would be, okay, and this would be X and X, right? Because X times X is X squared. Let's try the -2 and the 3. That would be -2X and then 3X. And if I combine those right there, I would get +1X. Hey! And so we got our answer. X plus 3 from the top and X minus 2 from the bottom. Hey, it's the same thing that we did before. Oh my goodness. That's crazy. X times X gives me X squared. X times 3 gives me 3X. So it's just another way of organizing it. And some of you guys might prefer that way. And so I just wanted to blast that out to you guys.